Hi guys, good morning. Hope you're all doing well.
Good morning, sir.
Good morning, good morning. Okay, so hope you're all ready. I'm seeing how many participants. I'm seeing almost 10 people. Okay, maybe we'll wait for 2 more minutes. Let me see if all the people join. Yesterday I saw almost 12 people joining. Okay, I'll just wait for 1 or 2 minutes and then we'll start. Guys, how many of you like studied in 10, like say studied in Epsilon Academy for 10th also and you're continuing in 11th? How many of you are like that?
I am, sir.
Okay, Hamsini, then?
Sir,
Okay.
I attended the crash course, sir, in 10th.
Okay. Crash course. Okay, crash course also is included. Anybody's like that? So I saw Hamsini and Harshida. So both of them. Then anybody else? Crash course or the 10th class you attended in this thing? Okay, fine. Only 2 of you. Cool. So maybe at least 2 of you would have seen me in your crash course, which I have taken. Okay. Cool then. I think we have enough people to start with. Let me share my screen. Start. So this is 11th and today's date is 13/06. Okay. Full screen. Okay, guys. So we were talking about the first chapter, some basic concepts of chemistry, right? So last class we spoke about, just give me one moment. Okay. Right. So we were speaking about some basic concepts of chemistry, right? So last class, if you remember, right, I was speaking about this atomic mass, right? Now, atomic mass, we define it like this. It is mass of one atom of an element divided by 1 AMU, right? And this 1 AMU is nothing but, what is it? Can someone tell me?
1/12 of mass of one C12 atom.
Correct. 1/12 of mass of one atom of carbon-12 isotope, right? So that is what we said. And then we went on to see the definition for moles. So just because we want to find what is the value for 1 AMU, we went on to see what is this moles, right? And I gave you 2 definitions, right? Can someone tell me first definition or any one definition? What do you remember?
It is a collective quantity.
Yes, that okay. Mole is obviously a collective quantity. It's like a dozen or say a pound or something. What is the definition? If I say 1 mole of a substance will have
6.023 into 10 to the power 23.
Yes, right. So 1 mole of any substance will have 6.023 into 10 to the power 23 particles of that particular substance. Say if I say 1 mole of banana, that means I will have this many number of bananas. Say if I have 1 mole of sodium, right? I told you when this particles I told you can be of 3 types, right? What are they? Atoms,
Molecules, and ions.
Yes, atoms, molecules, and ions. Okay, so now whenever we speak about elements, we speak about atoms, number of atoms. Whenever we speak about compounds, we speak about number of molecules. And whenever I have an ionic compound, we speak about ions. That we'll see later. How are you going to do it? Okay, now I have one more definition. That is, this is in terms of number of particles. What is the other definition?
1 mole weigh its atomic or molecular mass.
1 mole of any substance, right? 1 mole of any chemical species will weigh exactly its atomic or molecular mass. Right, that also we saw. Right, with the help of this, then we found out this 1/12th of mass of one atom of this thing, that is 1 AMU. I found out to be 1 divided by the Avogadro number. Avogadro number is nothing but the 6.023 into 10 to the power 23. That number is what is called as Na. Na is Avogadro number. Okay, so this is what exactly we saw last class. Okay, so we'll continue. Okay, so now that we know what is atomic mass is this one, that is the relative quantity. It is not mass of one atom of an element, right? It is a relative quantity, and we found out what is 1 AMU, we know what is number of moles, so we'll continue now. Okay, right, so let us continue, let us concentrate more on this number of moles. Okay, let us give you some examples, right? Fine, so right, say I have 1 mole of let me take something, carbon monoxide. Okay, 1 mole of carbon monoxide. Okay, now I want to know, obviously it will contain 6.023 into 10 to the power 23 molecules of CO. Yes, because that is what the definition says. 1 mole of any substance will have Avogadro number of particles. So since CO is a compound, right, we speak about molecules, right? And I also told you, if I have molecules, so many number of atoms, 2 or more atoms combined together to form molecules. Correct. So if I ask you in this question, if I ask you what is the total number of atoms, what will be your answer?
2 into Avogadro number.
Yes, absolutely right. Because we understand that in 1 molecule of CO, there is 1 carbon atom and there is 1 oxygen atom. Basically, totally 2 atoms are there, right? So this total number of atoms would be 2 into the Avogadro number. Okay, same way, if I ask you what is the, not total, what is the number of oxygen atoms, what will be your answer?
Avogadro number.
Avogadro number.
Absolutely. So you see that in 1 molecule of CO, there is only 1 carbon atom, or say only 1 oxygen atom. Correct? So I have this many number of molecules, each having 1 oxygen atom. So obviously, again, it is going to have Avogadro number of oxygen atoms. Same way, Avogadro number of carbon atoms. All that we can say. Right? And obviously, we know 1 mole of CO will weigh exactly the atomic mass or molecular mass. So now how will you calculate that? Can you tell me what is the molecular mass of CO? Molecular mass of CO, how will you calculate?
Atomic mass of carbon and atomic mass of oxygen.
28.
Right, 28, right? It will be 12 plus 16, right? That will be the atomic mass of carbon, and atomic mass of carbon is 12, atomic mass of oxygen is 16. So you will have totally 28 grams as the weight of 1 mole of carbon monoxide, right? Now I can even tell like this. I can tell like this, that 6.023 into 10 to the power 23 molecules of carbon monoxide will weigh 28 grams, right? So you don't even have to use moles, right? You can directly connect the number of molecules with the weight. Okay, right? Now I'll give you one more example. Let me see, like this, we're just, brushing up, right? Say if I have 2 moles of CH4. Okay, I have 2 moles of methane. CH4 is methane, right? First thing is, you have to answer all these questions. How many molecules, right? How many hydrogen atoms? Okay, first, how many total atoms, right? How many carbon atoms? And how many hydrogen atoms? And at last, weight. What is the weight or what is the mass of 2 moles of this thing? Try spend some 1 minute and try to get the answer, and you can put in the chat
Sir?
box. Yeah.
Sir, can we represent Avogadro number by some symbol?
Yeah, Avogadro number with symbol, I have NA, right? Where is it? See, they have here. N subscript A.
Okay, sir.
Okay, right. So answer all these questions. Don't unmute yourself and put. Just put in the chat box. All 1, 2, 3, 4, 5 questions are there. Okay. Now go for it. Put it in the chat box. I'm looking at the chat box. Okay, I have 2 moles of CH4, and I asked you all these questions. How many molecules, total molecules, how many total atoms, how many carbon atoms, how many hydrogen atoms, and what is the weight of 2 moles of CH4. So hope you're all sitting with a pen and a paper. Don't use calculators. Okay. So first question, Suprajit says 2 into Avogadro number. Second one, that is total number of atoms is 10 into Avogadro number. Okay. 2 into Avogadro number. 4.32 grams. Okay. Let's look at the questions. How many molecules, how many total atoms, how many carbon atoms, how many hydrogen atoms, and what is the total weight? Okay. 32 grams. Okay. Come on, guys, everybody participate. I want all of you to answer these questions. Doesn't matter if it is right or wrong, it's all about trying.
So can you once repeat that formula?
Can I what?
Repeat that formula of Avogadro number.
Formula, basically you want the number that is 6.023 10 to the power 23. That's the number.
No, sir. 1 AMU is equal to 1 by Avogadro number.
1 AMU is 1 by Avogadro number. That's the formula. What do you want to know exactly?
Like I didn't understand it clearly.
Oh, nothing. Like this, you can look into how we got this 1 AMU is equal to 1 by Avogadro number. If you look at the previous class, maybe I can show you. First, you answer these questions. I will show you. I'll take the previous slide and I'll show you. Right? You answer these questions. Now, AMU has nothing to do here. Like it has nothing to do. Right? You know, in 1 mole of CH4, all these things are there. So if you find for 1 mole into 2, into 2, into 2, into 2 for all of them, I'm going to get the answer. That's it. As simple as that. Okay, I'm getting more answers. Yes, go for it. Harshida answered. Sri Giridhar answered. And Suprajit Sahu answered. Come on. I have almost more than 10 people. Only 3 are answering. Go for it. Go for it. Doesn't matter if it's wrong. Okay.
Sir, what is the 4th question?
Yeah, the 4th question is how many hydrogen atoms?
Okay, sir. What is it?
Yeah. Okay, I'm seeing only still the same people answering. I don't see any new names in the chat. Okay, yeah, Navya answered. Huh? Nice. Vaishnavi. Simi. Guys, please don't say title. As in, I told you that doesn't matter if it's answer is right or wrong. It's all about trying. If you're not even going to try, how will you know whether you're right or wrong? Go for it. Go for it.
So can you show the question once again?
Sure. Arush, answer. Sir, I was not able to see the screen share. Can you tell me? Oh, Madhumita, you're not able to see the screen, Kanna, Madhumita?
Sir, so I was not able to see the screen because I had a weak network connection. Now I'm able to see it. So I want to know.
Sure. So what I'm telling is I have 2 moles of CH4. I'm telling you that, and I want you to answer all these questions. I want you to answer how many total molecules of CH4, total number of atoms, the number of carbon atoms, number of hydrogen atoms, and what is the weight of 2 moles of CH4. That's what I have to say.
Okay, sir.
Yeah. Okay, Bhargav answered. Ashwath, okay, nice. For 1 more. That's the mistake we do. It's good. At least you've got to know your mistake now itself. Nice. Arush, answering. Okay. So mass and weight in chemistry, we generally don't discriminate. But yeah, actually it is different, obviously, right? It is, we write weight as, what is that? Kg per, what is it? It's
We calculate it like it is force.
Exactly. We with respect to the gravity, we calculate. Mass is not with respect to gravity, but still in chemistry, we don't actually discriminate between mass and weight. But yeah, correctly speaking, we should be discriminating, but still doesn't matter much. Okay, fine. I got almost good answers, right? You can keep on putting the answers. You can just keep on calculating. By that time, I will help you to get the correct answers. Okay, right. So first things first, right? Now, if I gave you 1 mole, all the things were very easy, right? Because I know 1 mole, what is the definition, right? So if there are 2 ways of doing this, people, right? You calculate for 1 mole, what are all the answers to all these questions, and then you multiply all of them by 2 because I have 2 moles, right? Or you can, whatever the method you want, you can follow, right? First thing, right? Now, okay, so I write 1 mole of CH4 will contain 6. I'll write for the simplicity, I'll write just write 6 into 10 to the power 23 molecules of CO. Okay, Now, what they're asking, if I have 2 moles, how many?
Sir, it is,
I'll put it
sir,
as
it is
CH4, sir.
so CH4, sir. You put it as carbon monoxide.
Oh, sorry. So this is CH4. Thank you. Right. Okay. So 1 mole of CH4 I know is going to have Avogadro number of CH4 molecules. So if I have 2 moles, put it as X. I told you this cross multiplication will help you so much. Okay. Now I gave you 2 moles, so easily you can calculate. But what if I gave you like 5.3 moles? Right? At those things, you cannot directly calculate. So what do? You always go for this cross multiplication. It will always help you. Always help you. Okay, so 1 mole of CH4 is this much, 2 mole is how much? Now you cross multiply and you find out. So X would be 2 into the Avogadro. Okay, so basically what you're talking about, this number of molecules, total number of molecules is 2 into the Avogadro number. That's the total number of molecules of CH4 present. Okay, fine. Same way, I write 1 mole of CH4. Can I write it like this? I have 4 into Avogadro number of, sorry, not 4, 5. Sorry. Right, 5 into Avogadro number of total number of atoms. Can write it like this, right? Easy, right? So I have CH4, I have 1 carbon atom and 4 hydrogen atoms, right? 1 carbon atom and 4 hydrogen atoms. Totally, it is going to be 5 atoms per molecule. And how many molecules I have? In 1 mole, I have this many molecules, right? So same way, in 1 mole of CH4, I have 5 into Avogadro number of atoms, total number of atoms. But what I need is for 2 moles. Again, you put it as X and you cross multiply, right? So you will get the X value as 10 into the Avogadro number. So total number of atoms here would be 10 into Avogadro. Simple. Same way, I'll be able to calculate for carbon atoms. I can write 1 mole of CH4 contains how many carbon atoms? So I can write Avogadro number of carbon atoms. Is it not? How? Because I know in 1 molecule of CH4, I have only 1 carbon atom. There's only 1 carbon atom, right? So if I have 1 mole containing Avogadro number of molecules of CH4, each molecule having only 1 carbon atom. So obviously in 1 mole of CH4, I can tell that there is Avogadro number of carbon atoms, right? So obviously in 2 moles, I'm going to have 2 into Avogadro. Again, you can put it as X and cross multiply. So the number of carbon atoms would be 2 into Avogadro. Right? Okay, fine. Now, what about hydrogen atoms? Now, very simple, right? In 1 molecule, I have 4 hydrogen atoms, right? In 1 molecule, I have 4 hydrogen atoms. So in so now I have this many number. Okay, what is the total number of molecules? Total number of molecules is 2 Avogadro number, right? Each molecule having 4 hydrogen atoms. So can I write this as 8 into Avogadro number? Again, if you're getting confused, we can write like this, right? 1 mole of CH4 contains 4 into Avogadro number of hydrogen atoms. Is it not very simple, right? Because 1 molecule contains 4 atoms. So Avogadro number of molecules will contain 4 into Avogadro number of hydrogen atoms. Same way, for 2 moles, it is going to be 8 into Avogadro. And that's what we exactly wrote here, right? 8 into Avogadro number of hydrogen atoms. Okay, fine. Coming to the last question, what is the weight or mass, right? So I know 1 mole of CH4 will weigh exactly its molecular mass. So carbon is 12, hydrogen is 4, that is 1 hydrogen 1, so 4 hydrogens 4, so it will be 16 grams, right? Okay, so same way for 2 moles, it is going to be 32 grams. So the answer to the last question is 32 grams. Okay, so I hope most of you have gotten all the answers correct. Some of you were, some answers were wrong, but most of you have gotten all the things correct. Okay, a very good attempt, very good attempt. Okay, so I hope everybody understood how all these answers came. Right, maybe we'll solve one more question. Right, let me make the numbers a little tricky now. Okay, say, let me put it like this. I have 66 grams of carbon dioxide. Okay, I have 66 grams of carbon dioxide. Now the questions are, first question is W, how many moles? Second question is, how many molecules? Third question is, how many atoms, total atoms, right? How many carbon atom? And the fourth question is, how many oxygen atoms?
Sir,
Okay, yeah,
sir, I have a doubt, sir.
please go on.
Sir, if they ask how many atoms, so should we write how many atoms in the carbon dioxide molecule or in terms of Avogadro number?
Like the number of atoms will be in terms of Avogadro number only, right?
5
You have to tell
into,
the exact.
I mean, sir, 3 into Avogadro number.
Yeah, correct.
Not like three.
One mole. Yeah, wait. 1 mole of carbon dioxide will have 3 into Avogadro number of total atoms. Yes.
Okay, sir.
Right. Okay. But you should not write Na. Like now we are okay writing Na, but in your exams you have to calculate these values, guys. You have to put the value of Avogadro number as 6.023 divided by 23 and give the exact value. But for now, for the sake of simplicity, we just write 5 into Na, but you have to calculate it properly.
Okay.
Okay, right? Yeah. Now answer all these questions. I have 66 grams of carbon dioxide. I want to know how many moles. See, the cross multiplication is going to help you so much, right? Please remember that. Again, you can put the answer in the chat box once you complete. Okay, I got answers. Raghav says first one is 1 company. Can the number of atoms and molecules be in decimals? It will not be in decimals, even if you get something like some 3 point something, but what you have is 10 power 23. So it won't be decimal. I'll have that many zeros, 23 zeros you have to add. So basically you will see that it is going to be a whole number only. Okay, Raghav? That's good. Okay.
Can you show the questions?
Sure. Nice. Okay, okay. Either Vaishnavi, I'm seeing all the chats. I'll give you 2 more minutes for everybody to answer, and then I will help you. This. Yes, I'm seeing it.
Sir, can you just show the questions?
Yeah. This, what to say? Looking at the chat and making it full screen is actually a little problem. Hold on. Perfect. Answers. Good, good, good. Okay, maybe guys, it's time. I will help you. Okay. Fine. Now, concentrating here. Right. So again, I am just going to use the cross multiplication. Nothing magic. Nothing I'm going to do. Okay. Right. So first, I know I'll calculate for 1 mole. I know every definition I know for 1 mole of CO2 will weigh exactly the atomic mass or molecular mass. And if you calculate, it will be 44 grams of carbon dioxide. How 44? 12 for carbon, 16 into 2 for oxygen. 1 oxygen 16, 2 oxygen 16 into 2. Totally you'll get 44 grams. Okay. Now what they have given here, they have given that I have 66 grams of carbon dioxide, right? So let me put X here because I have to find the number of moles. So again, cross multiply, you will find that X is basically 66 divided by 44, which is 1.5 moles. So the first answer we got 1.5 moles. And rest all the questions are going to be exactly similar to the last case. Instead of 2 moles, I have 1.5 moles. That's the only difference. Okay, now you can easily calculate now, right? So for 1 mole of carbon dioxide, I have Avogadro number of molecules of carbon dioxide. Right now, how many moles I have? I have 1.5 moles. So keep it as X and cross multiply. You will find that X is 1.5 into the Avogadro number of molecules of carbon dioxide. Right? So the answer to this question is 1.5 Na, Avogadro number. Okay. Now, how many atoms? I will look into it. So I have 1 mole of carbon dioxide contains, can I say, 3 into the Avogadro number? Because I know 1 molecule of CO2 contains 1 carbon atom, 2 oxygen atom, totally 3 atoms, right? So I have Avogadro number of molecules, total number of atoms would be 3 into the Avogadro. Very simple, right? Again, what I have is 1.5 moles for that X. Again, cross multiply, you will find X to be
4.5 into Avogadro
4.5 into Avogadro. Absolutely, right? So this would be 4.5 into Avogadro number, right? Same way I can calculate. For now, there is only 1 carbon atom per molecule of CO2. So this is also going to be number of molecules and number of carbon atom is going to be same, right? Again, this also is going to be 1.5 Avogadro number. And you see for 1 molecule, I have two oxygen atoms, right? For 1 molecule of carbon dioxide, I have 2 molecules of oxygen atom. So if I have this many molecules, twice will be the number of oxygen atoms. So I will have 3 into Avogadro. Right? Again, I repeat, people, now for the sake of simplicity, we write Na 4.5, Na 3, Na, all that. But in your exams, you have to put the Avogadro number value as 6.023 into 10 to the power 23 exactly and calculate and give the answer. Okay. Again, most of you have gotten the answer very correctly. Very good. Very good. Right. Fine. So we'll move on. I think this question, I hope everybody understood. Right. Okay.
Sir, I have a
Moving
doubt.
on. Yeah, please come tell me.
Sir, I find difficulty between molecules and atoms, sir. Can you once say?
Okay. Okay, sure. So now all you have to understand is molecule. When I talk about a compound, right? A compound is made up of molecules, right? And second layer, if you go, molecules are made up of atoms, right? This you understand the hierarchy. Compounds are made up of molecules and molecules are made up of atoms. Is this point clear, Kana?
Yes, sir.
Okay. Now, if this is clear, now look at this question, right? Now, first, per molecule, right? If you look at per molecule of any compound, right? How many atoms you'll be able to calculate, right? Now, look at this. I have 1 molecule of CO2, right? Now, forget about moles, right? I'm telling you 1 molecule of CO2 contains how many atoms? 1 carbon atom, 2 oxygen atoms, right? So many atoms come together to form a molecule. I'm telling 1 molecule of carbon dioxide contains 3 atoms. How 3 atoms? 1 carbon atom and 2 oxygen atoms. Correct. Now, if you find what is the total number of molecules present, right? If you find the total number of molecules present, and you know in each molecule how many atoms are there, right? Now look at this. I found out that the total number of molecules is 1.5 into Avogadro number, right? Now, each of the molecule of carbon dioxide contains 3 atoms, right? So if I have to find the total number of atoms, should I not multiply this by 3, right?
Yes,
because 1 molecule contains 3 atoms, so 1.5 into 3 will become 4.5 into the Avogadro number. That is what is the total number of atoms, right? Now, same way, if this is about total atoms, now you will consider individual type of atoms I have. I have only 2 types of atom, carbon atom and oxygen atom. Right. Now, in 1 molecule of carbon dioxide, how many carbon atoms are there? 1 carbon atom, right? 1 carbon atom. So can I say this many molecules will have same number of carbon atoms? 1 molecule contains 1 carbon atom. So this many molecules will contain this many carbon atoms. Simple. Same way for 1 molecule of carbon dioxide, you see only 1 molecule I have. In that I have 2 oxygen atoms. Correct. So if I have this many molecules of carbon dioxide, each molecule having 2 oxygen atoms. So if I have to find the total number of oxygen atom, this total number of molecules into the number of oxygen atom per molecule. Per molecule it is 2. So this into 2 will give you 3 into Avogadro. Is it clear, Kanna?
Yes, sir.
Okay, fine. Good. Right, move on. Oops. Why did I make it? Okay. Now now guys, we are using cross multiplication method very efficiently now. Correct. Now, just for the sake of simplicity, I am going to give you some formulas also. Okay. Now this formula, I think you already know. Now number of moles is denoted by the letter N, right? N is the number of moles. N is equal to given mass divided by the molar mass. Molar mass can be either atomic mass or molecular mass. Okay, one number of moles is given by given mass divided by molecular mass. Given mass is what is given to you in the question. Right? Say in this question I gave you, if you look at this question, I gave you that I have 66 grams of carbon dioxide. That is what is the given mass. Right? So if you want to calculate the number of moles, you can directly put it in the formula. 66 is the given mass. Molecular mass of carbon dioxide is 44. So again, you're going to get the same answer, 1.5 moles. Okay. Now, this is in terms of mass. I can even have the this thing in terms of number of particles. So it will be given number of particles divided by Avogadro. Right. Say for example, if I give you 3 into 10 to the power 23 CH4 molecules are there. Right, 3 into 10 to the power 20 CH4 molecules are there. I ask you what is the number of moles. This is the given number of particles, right? So N would be 3 into 10 to the power 23 divided by what is the Avogadro number? Approximately, I'm telling 6 into 10 to the power 23. So you will get 0.5 moles, right? So if at all you're comfortable with what is that? If at all you're comfortable with cross multiplication method, you can go for it. If you're comfortable with the formula, you can go for it. A molecular this mass equation, no problem, right? But when you come to this particles equation, right? Remember that I will be able to use, if at all I have elements given, I'll be able to find the number of atoms. If at all the molecules, compounds are given, I'll be able to find the molecules, number of molecules. But you cannot directly find the number of atoms. That's the problem here. Okay, maybe what you do is you find the number of particles and then you go for, say, the number of molecules you find, and then from the number of molecules you find the number of atoms. Okay, but anyways, don't get confused. You can, like I would say, this formula I don't use it. Okay, whenever you are talking on in terms of number of particles, you always go for cross multiplication. But whenever you have mass, then you can use the formula. That will be a very good thing. Okay, this formula you don't. Yeah, go for it.
Sir, in this number of particles, you have mentioned it as 6 into 10 to the power 23, sir. So in exams, can we write, for simplification, can you write?
No.
We
You
should
have
only
to write
use
6.023 into 10 to the power 23. That's what you have to
Okay.
write. But if at all you go for competitive exams, JEE Mains, NEET, at that time you can approximate it to 6.
Okay.
Okay, but for your school exams, they will cut marks if you're going to write it as 6.
Okay.
Okay, right. Fine. So let me ask you maybe one more question, and then we'll continue after that. Okay. Say I have okay, 4.5 into no. Right. 4.5 into 6 is how much? 4.5 into 24. 5 will be 3. Correct. 4.5 into 6 is 24. 24 plus 3 is 27. Okay. So I have 27 into 10 to the power 23 atoms of oxygen present in Al2O3. Okay, I have 27 into 10 to the power 23 atoms of oxygen atom. There are this many number of oxygen atom present in some sample of Al2O3. Okay, now first question is how many moles? Okay, this is the first question. Second question, total molecules of Al2O3. Third, total atoms. Fourth, number of total aluminum atoms. And fifth one is mass. Okay, go for all these questions. Now see, this 27 into 10 to the power 23 is not the number of molecules, guys. It is the number of oxygen atom present in some amount of Al2O3. Now with that data, you have to answer all these questions. Take some time, answer these questions. So it need not be, you need not go by the order 1, 2, 3, 4, 5. Whichever question you want to answer first, you can answer. And use the Avogadro number value as 6 into 10 to the power 23. Okay, don't write NA, you will not get the answer. Okay, use the Avogadro number value as 6 into 10 to the power 23. Guys, I want to change the question a little bit. Keep this as 20. Yeah, keep this as 24 and not 27. Okay. Now I'm giving you this because the calculation will be easier. 27 will be a bit tougher calculation. Keep this as 24. Yeah. Okay.
So can you show the question, sir?
Just looking at the answers. Guys, if you're wondering, what is the atomic mass of aluminum, guys?
27. 27.
Yeah, 27. If you don't know that, you will not be able to answer the mass question.
Sir?
Yeah.
Sir, Al2O3 is a compound, right? So in that, can we say there are two molecules?
I don't understand. Al2O3 is a compound. Okay.
Yes. Can we say that there are two molecules present in Al2O3?
No, unless and until you don't know anything about the number of moles. If I say that if I have 1 mole of Al2O3, I will have Avogadro number of molecules of Al2O3. How is it 2? I can tell that in one molecule of Al2O3, I have 2 aluminum atoms. That I can tell. Yes?
No, sir. What I meant was Al2 is a separate molecule and O3 is a separate molecule. So there are two molecules.
No. Al2O3 is an entire one compound. That's it. Okay, it's aluminum oxide. Al2O3 is aluminum oxide, entire compound. Just like how you have CH4, CO2, all this stuff, Al2O3 is also compound. One single compound, one single entity.
So then what is the total number of molecules present in Al2O3? Na into Na? Is it Na?
If it is 1 mole, yes, it is Na, but you have to calculate the number of moles, then only you can tell, right, how many molecules will be there. Are you understanding what I'm saying, Kanna? If I know
Yes,
the
sir.
number of moles of Al2O3, then only I can talk about how many molecules are there. If you don't know, if you don't have the data about number of moles, how will you tell how many molecules will be there? Right?
Yes, sir. Got it, sir.
Okay, cool, nice. See the chat box. Announce its game. Okay. 4 408 grams. 4 moles. Okay. See so many of your answers. Good. Please go on. If anyone wants to see the question, please let me know. I'll show you the question. For now, we'll save the chat box.
Sir, can you show the question?
I'll give you 1 more minute or 2 more minutes. Time is 12:26. By 12:28, I will start answering the questions. For any problem, you should find the number of moles first. Not necessary, Kana. Whatever you're comfortable with, you can do that. But number of moles, if you find, the other things will automatically come out. But if you're comfortable with finding anything else, you can go for it. There is no restriction like that. Okay, I think now I'll try to answer the questions. Right. Okay. So they have given 24 into 10 to the power 23 atoms of oxygen is present. And first question is how many moles? Okay. Now I can directly tell that 1 mole of Al2O3. Now we'll directly calculate in terms of number of atoms directly. Right? Now, or I can calculate in terms of number of oxygen atoms. Or if at all you are so much confusions, right? Now, let me put it like this. I have 1 mole of Al2O3 will contain 6 into 10 to the power 23 molecules of Al2O3. This is okay, right? Now I have 1 molecule of Al2O3 will contain how many atoms? 3 oxygen atoms. Okay, 1 molecule of Al2O3 contains 3 oxygen atoms. Very simple. Correct. So now in 1 mole, I have Avogadro number of molecules of Al2O3, right? And in 1 molecule of Al2O3, I have 3 oxygen atoms. So can I tell that in 1 mole of Al2O3, I have 6 into 3 into 10 to the power 23 atoms of oxygen. I'll be able to tell like this, isn't it? Because 1 mole contains this many molecules and 1 molecule contains 3 atoms. So total number of atoms of oxygen in 1 mole of Al2O3 will be 6 into 3 into 10 to the power 23, which is basically going to be 18 into 10 to the power 23. Okay, right. Now this I'm having in 1 mole. Okay, now look at what they have given. They have given that I have 24 into 10 to the power 23. You can look at here. You can see that I have 24 into 10 to the power 23 atoms of oxygen, right? So now I can, maybe I'll write it again. So 1 mole contains 18 into 10 to the power 23. Now what I have is basically 24 into 10 to the power 23. Let me calculate X. That was the number of moles. So cross multiply, find out that X would be 24 divided by 18. I think it is 1.5 moles. Is it? 18.
1.75.
1.75. Okay, fine. So it is 1.75.
Sorry, sir, 0.7.
How would it be 0.75? 1.75 only. It's correct. Right? 9, 12 times. This is 3 times. This is 4 times.
0.7.
Sorry. 4 by 3 is what I have. Or is it? Oh, wait. So this will go here and this will come here. So it will be 24 divided by 18. Whatever I'm doing is correct. So if I do it in 3 tables, it will be 8 times, and this will be 6 times, and this would be 3 times, and 4 times. So 4 by 3 will be 1.666, correct? Right? Okay, I thought I'll make the calculation easy, but it is becoming difficult. But still, don't worry, guys. Right? So X is what now? X is 1.666 moles. Okay, it keeps on going. 1.66666. It keeps on going. Okay, so I hope everybody understood. Okay, maybe I'll repeat again. Now I know 1 mole of Al2O3 contains Avogadro number of Al2O3 molecules, right? And in 1 molecule of Al2O3, I have 3 oxygen atoms. So what will be total number of oxygen atoms in 1 mole of Al2O3? 6 into 3. That is 18 into 10 to the power 23 atoms of oxygen are present in 1 mole.
Sir, isn't it 1.33 moles?
So it will be correct. It's 1.33. Yes, absolutely correct. Right, it will be 1.33, whatever, 1.33 moles, right? So now I can calculate 1 mole contain this many oxygen atoms. So if I have 24 into 10 to the power 23 oxygen atoms, what will be the number of moles? And that we calculated as 1.33. Okay, done. The first question is answered. First question, how many moles? It is 1.33 moles. Done. And after that, all the questions are very easy, exactly like we did in the previous case. Okay, fine. Maybe you, yeah.
Sir, we were given the second formula, sir. The given number of particles divided by Avogadro number gives the moles. Can't we use that?
Yes, that's a very good question. Now we cannot use that because I told you only if if this question was 24 into 10 to the power 23 molecules of Al2O3, then you could have used that formula. But what is given here is number of oxygen atoms, right? So if at all you want to use the formula, you have to first find the total number of molecules. Then you find the number of moles. That you can do. That is why I told you don't use the formula. It is a little confusing. Okay?
Okay, sir.
Right? Okay, cool. So now we calculated number of moles. Now all the things, other things are very simple, right? So for 1 mole, it is 6 into 10 to the power 23 molecules, right? So I have 1.33 moles. You can find the X value. You can calculate. So that will be 6 into 1.33 into 10 to the power 23. So that answer we got. So you can calculate. I don't want to spend time in calculation. So same way total. I think, guys, you want me to calculate everything? Now that you know the number of moles, everything else will come out. Right? I hope I can skip this. Is everyone okay with this?
Yes,
or you
sir.
want me to calculate everything? Okay. Now this value alone will be little difficult. That if you find out, all the other things are going to be similar to the previous questions. Okay? Right? Very simple. Very, very simple. Okay. Cool. Now we'll move on. What is the time? Okay, we have almost half an hour. Okay. Now I am going to give you, we spoke about atoms, we spoke about molecules, but we didn't speak about ions, right? Like I told you, particles can be of 3 types: atoms, molecules, or ions, right? Now, for example, I tell you that I have, say, some 2.5 moles of magnesium chloride. I know it's an ionic compound, correct? Right? Now, please understand, people, if I take 1 molecule of MgCl2, can I tell that there is 1 Mg2 plus ion and 2 Cl minus ions? Can I tell this? Does everybody agree with this statement, what I told?
Yes, sir.
Okay. So I know obviously the ions present are Mg2 plus and Cl minus. So in 1 molecule of MgCl2, I will have 1 Mg2, that is 1 ion of Mg2 plus and 2 ions of Cl minus. Okay, so if I give you that there are 2, so I can tell that in 1 mole of MgCl2, I can tell that there is going to be, obviously Avogadro number of MgCl total atoms will be there. If I directly go for ions, can I tell that there will be Avogadro number of Mg2 plus ions and 2 into Avogadro number of Cl minus ions. Yes, this makes sense, right? 1 mole will contain Avogadro number of total MgCl2. And each MgCl2 is getting what? Each MgCl2 is containing 1 Mg2 plus and 2 Cl minus. Correct. So if I tell you that if I have 1 mole of MgCl2, I will have Avogadro number of Mg2 plus and 2 into Avogadro number of Cl minus. Just exactly what it did for atoms. Same thing we are doing in terms of ions. The simple, very, very simple thing. Okay, so now you know everything for 1 mole. Maybe now you can calculate for 2.5 moles, right? So first we'll calculate for Mg2 plus. So 1 mole, okay, look at the statement. So 1 mole contains Avogadro number of Mg2 plus. So 2.5 moles will contain 2.5 into Avogadro number of Mg2 plus ions. Same way, 2.5 moles will contain 2.5 into 2 into Avogadro number of Cl minus ions. Yes, everything makes sense here. I want everybody to give me yes if you understood in the chat box. Go for it. Or you can unmute yourself and speak. Just give me yes if you understood whatever we saw now. Okay, 1, 2. Come on, guys. Everybody understood? Yes, 3, 4.
Yes, sir.
5, 6, 7. Only 7 are there. I know more than 10 people are there. Okay. Okay, cool. I hope everybody understood. See, I'm just making you say yes just for my satisfaction, because if I have the confidence that you understood, then I can then I will have my confidence that I can easily move on to the next thing. And that's the reason why I ask you to say yes or no. If it is a normal classroom, if it is an offline classroom, by looking at you itself, I can tell. By looking at your looking at your face itself, I can tell whether you understood or not. But that luxury we don't have right now. Right? That's why I ask you to say yes. So please don't mind. Okay, so I hope everybody understood this. So same kind of questions can be asked in terms of ions also. That's all I want to tell you. Okay, now this we understood. Now we'll move on. Now I already have 2 definitions of moles. One says that 1 mole of any substance will have Avogadro number of particles in them. And second definition says 1 mole of any substance will weigh exactly its atomic mass or molecular mass. Now I have one more and last definition for moles. Okay, now third definition of moles, right? Now we spoke in terms of number of particles, we spoke in terms of mass. Now here we are going to speak in terms of volume. Okay, here we're going to speak in terms of volume, and this is applicable only for gases. Please remember this. Okay, the definition which I'm going to give you now is applicable on and only for gases. Solids, liquids, no, this doesn't work. Okay, now the statement goes like this: 1 mole of any gas at STP, we'll come back to this. What is STP? 1 mole of any gas at STP will occupy a volume of 22.4 liters. This is the exact statement. Okay, 1 mole of any gas at STP will occupy a volume of 22.4 liters. Now, if we just take out this STP, now you can easily understand 1 mole of any gas, just like how I have number of particles and mass, just like that I tell them 1 mole of any gas will have a volume of 22.4 liters. Right. Now we'll concentrate on what is STP. STP is standard temperature and standard pressure. Okay, and these are some constant values. Now remember, standard temperature is 0 degrees Celsius, or you can write 273 Kelvin. Hope you all know how to convert Kelvin to degrees Celsius, right? And standard pressure is 1 atmospheric pressure, 1 atm. Okay, so only if these conditions are satisfied, only if standard temperature and pressure is there, only at this STP, this value holds good. Okay, so if at all you don't have STP, 1 mole of gas can have some other volume. It is not going to be 22.4, right? Okay, so the statement says 1 mole of any gas at STP will occupy a volume of 22.4 liters and standard
Sir?
temperature. Yeah.
Sir, any element can be converted into a gas.
Any element can be converted into a gas? Yes, theoretically, yes.
So this would work for all the elements, right?
No, like when at that particular C for like, okay, we'll assume the situation. I want to convert sodium solid into sodium gas. Okay, you know at what temperature it will happen? It will happen at some 800 to 1000 degrees Celsius. Only then I will be able to convert sodium solid into sodium gas. Now, what is the temperature I told you? Temperature was some 800 to 1000 degrees Celsius. Now, does it match with this STP?
No, sir.
So that is why we mentioned this. Standard temperature and pressure conditions should be satisfied. At these conditions, yes, 1 mole of any gas will have 22.4 liters. Okay?
Yes, sir. Got it, sir.
Right. Good. Right. So now I can give you, maybe I'll give you an example. Say, if I tell you that 11.2 liters of oxygen gas at STP is present. Okay, 11.2 liters of oxygen gas at STP is present. And I ask you, what is the number of moles of oxygen? What will be your answer?
2 moles.
Look at it carefully and tell me. 1 mole is 22.4. So 11.2 will be?
Sorry, sir, 0.5.
0.5 moles.
Correct, correct. So this will be me. This means that I can have 0.4 moles of, 0.5 moles of oxygen. That's what it means. Okay, now I'll be able to give you a formula also in terms of volume. So number of moles is equal to given volume divided by 22.4. I'm sorry. Right, given volume divided by 22.4 liters. Just like how you have given mass by molecular mass, given number of particles divided by Avogadro number. Now this will be given volume divided by 22.4 liters. Okay, right? Maybe we'll do, what is the time? Okay, we have 15 more minutes. Maybe I'll just give you one problem and then we'll wind up. Okay. Now I have, see, I can connect everything now. I can connect mass, molecules, Avogadro number, atoms, volume, everything can be connected now because everything is connected to number of moles. Okay, so we will solve one question which will connect everything, right? Okay, now I am going to give you, say, let me think of a question. Okay, so let me take ethane. Ethane is a gas, okay, C2H6. Okay, I'm telling that, okay, so I have 54 into 10 to the power 23 atoms of hydrogen in some amount of C2H6. Okay, I have in some amount of C2H6, I found out that I have 54 into 10 to the power 23 atoms of hydrogens are there. Right, now the question is, first question, how many moles? Second question, total molecules. Third question, total atoms. Fourth question, number of carbon atoms. Fifth one, mass. And the last question is volume. Okay, right, go for it.
So what is it that you wrote in the first one, sir? Like H6 and from in the top.
Oh, C2H6. This is okay. C2H6. Ethane gas. Actually, fine. Okay, go for it. Go for it. Go for it. And use the Avogadro number as 6 into 10 to the power 23. Okay. Okay, some answers. Okay. Let's see, let me know if you want to see the question in the chat box.
Sir, can you show the question?
Yeah.
Sir, sir, you can scroll the screen to right side so you can see both the chat and yes, sir.
Oh, okay.
No, sir, you can
okay.
also see the chat and the students can see.
Oh, understood. Understood what you're telling. Okay, okay. How will I do this?
Sir, it would be in the bottom, sir.
Or I can hide it. Okay. This is better.
Yes, sir.
Okay. Now I will do. See all the questions. Maybe I'll give you one more minute for everybody to answer. 12:55 and answer the questions. Okay. Fine. Okay. Yeah. Give some answers. Okay. Cool. Right. So let us answer the questions. Right. So this is like a previous question where I gave you like this. Where is it? Where was it? So that's like this question: 24 and 23 atoms of oxygen present in aluminum oxide. Similar questions. So like I will answer only two questions. I will answer this one and the volume part. Rest all are very easy. Again, we have solved it so many times. Okay, fine. But I can directly give you the answers if you want. No problem. Okay, so again, I write like this. 1 mole of C2H6 will contain, can I directly say, guys, it is 6 into Avogadro, 6 into 6 into 10 to the power 23 atoms of hydrogen. I can directly tell, isn't it? Because 1 mole of C2H6 contain Avogadro number of molecules of C2H6, and each molecule contains 6 hydrogen atoms, right? So total number of hydrogen atoms in 1 mole of C2H6 is basically 36 into, what is that? 10 to the power 23 atoms of hydrogen. Okay, now what they have given us, that I have 54 into 10 to the power 23 atoms of hydrogen. So if you calculate X, now X you will find out to be 1.5 moles. Done. Okay, now I can easily calculate mass and volume directly with the formula, right? So number of moles is 1.5. Given mass, I don't know. Divided by molecular mass of C2H6 would be, I think, 24. 24 plus 6 is 30, right? So mass would be how much? 30 into 1.5, which will be 45 grams, right? So mass will be 45 grams. Same way I can use the volume formula. Number of moles is equal to given volume divided by 22.4 liters. So I can write given volume, I think, as 33.6 liters, right? If you calculate, you will get it as 33.6 liters. And total number of molecules is very simple. Now 1.5 moles, so total number of molecules would be 1.5 into the Avogadro number. Total number of atoms would be 1.5 into 1 molecule contains how many atoms? 2 carbon atoms, 6 hydrogen atoms, totally 8 atoms, right? So it will be 1.5 into 8 into Avogadro number. So 1.5 into 8 plus 4 will be 12. So this will be approximately, okay, I don't have the space, I'll not write it here. This will be approximately 12 into 10 to the power 23. Right. 12 into Avogadro number, sorry, 12 into Avogadro number. 12 into Avogadro number would be 12 into 6, which would be 72 into 10 to the power 23. Okay. Now, number of carbon atoms. Now, 1 molecule contains 2 carbon atoms. So I have 1.5 moles. They will contain Avogadro number of 2 into Avogadro number of, wait, first, I'll see slowly. So, I have 1.5 moles. Okay. 1 mole contains 2 into Avogadro number of carbon atoms. No issues. 1 mole contains 2 into Avogadro number of carbon atoms. Right. So 1.5 moles will contain 1.5 into 2 into Avogadro. No issues. Right. So all the questions are answered. Okay. Right. So I think most of you got everything correct. Right. So this is how you solve the problem. So only one thing extra we did here from the previous question, we found out what is the volume. Volume is 33.6 liters. That's the only thing we did extra. Okay, fine guys. If you have any other questions, you can ask me or else wind up the class. Any questions you have?
Yes, sir. Sir, in
okay,
C2H6,
you have a question? Yeah, please
yes,
go
sir.
for it. Go for it.
In
Yeah.
C2H6, there are both atoms of carbon as well as hydrogen, sir.
Yes, yes, correct.
So we have in 1 mole of C2H6, we are only considering 6 atoms of hydrogen.
Okay, correct.
Why not?
In one molecule of C2H6, we are considering 6 atoms of hydrogen. Yes.
It's not 1 mole.
No, 1 mole, see, I've written here. In 1 mole, how many atoms of hydrogen? 6 into 6. How 6 into 6 came? 1 mole of C2H6 will contain 6 into 10 to the power 23 molecules of C2H6. Each molecule having 6 hydrogen atoms. So total number of hydrogen atoms will be 6 into 6 into 10 to the power 23.
Sir, this can
Yes.
also be written in terms of carbon atoms, right?
Yes, if I write it in terms of carbon atoms, 1 mole of C2H6 will contain 2 into 6 into 10 to the power 23. Yes, absolutely. Absolutely.
Okay, sir.
Yes, understood?
Yes.
Okay, good. Right. Fine, guys. Any other question? Okay, I hope there are no questions. Okay, guys, thank you so much. We'll meet again next week.
Thank you, sir.
Thank you.
Thank you,
Yes,
sir. Have a
sir.
great day.
Everybody. Thank you.
Thank you so much.